PVC conduits are indeed suitable for use in a service under the specified conditions. Firstly, concerning the use of PVC in direct contact with concrete slabs, PVC is perfectly acceptable. Its material composition allows for direct encasement without degradation. Secondly, regarding its use in a meter main module, PVC conduits are commonly employed for service entrances due to their insulating properties and ease of installation. Thirdly, in an open garage space, PVC corrosion resistance makes it well suited to withstand moisture and ultraviolet light exposure typical in such environments. Fourthly, considering its location at ground level under a multi-family building, provided the conduits are not subject to excessive loads or physical damage, PVC remains a viable option. The protection offered by the surrounding concrete structure further minimizes the risk of physical damage to the PVC conduits. With an all-concrete surrounding structure, the concrete provides an additional layer of protection for the PVC conduits, enhancing their durability. Let's discuss additional considerations specific to Miami Beach, Florida. Firstly, in terms of hurricane resistance, PVC conduits, when properly installed according to the manufacturer's instructions, generally meet the hurricane resistance requirements outlined in the Florida Building Code. Secondly, when we look at the heat and humidity prevalent in Miami Beach, while PVC conduits can withstand these conditions, extreme heat can lead to expansion and contraction. Therefore, the incorporation of proper expansion fittings becomes crucial. Let's cover installation requirements. Firstly, the PVC conduits must be installed in strict adherence to the National Electrical Code, referred to as the NEC, and all other applicable local codes. Secondly, proper support and securement of the conduits are essential to prevent sagging or potential damage. Thirdly, expansion fittings must be strategically placed to accommodate thermal expansion and contraction, mitigating stress on the conduit system. Let's delve into the specific requirements within the NEC that pertain to PVC conduit installations. NEC Section 352 covers PVC conduit. This section outlines the approved uses, installation requirements, and limitations of PVC conduit. Key considerations include proper support, expansion fittings, and protection from physical damage. Article 300 of the NEC addresses general wiring methods and materials. This article provides requirements for protecting conductors and cables, including those installed in PVC conduit. Pay close attention to the sections addressing underground installations, raceway support, and protection against physical damage. Article 310 of the NEC focuses on conductors for general wiring. When selecting conductors for use in PVC conduit, consider the ampacity ratings, insulation types, and temperature limitations specified in this article. Ensure that the conductors are suitable for the environmental conditions and voltage levels of the installation. Article 230 of the NEC covers service entrances. This article provides requirements for the service conductors, service equipment, and service raceways, including PVC conduit. Pay close attention to the sections addressing underground service laterals, service masts, and protection of service conductors. Article 250 of the NEC addresses grounding and bonding. Proper grounding and bonding are essential for electrical safety and to minimize the risk of electric shock. This article provides requirements for grounding electrodes, equipment grounding conductors, and bonding of metal components, including those associated with PVC conduit systems. Ensure that the PVC conduit system is properly grounded and bonded in accordance with the NEC requirements. One common issue is determining the correct spacing for conduit supports. The NEC specifies minimum support intervals for PVC conduit to prevent sagging or damage. For example, for trade size 1-inch PVC conduit, supports must be provided at least every 3 feet as per NEC section 352.30. It's important to always consult the latest edition of the NEC and local codes for the most up-to-date requirements. The proper selection of expansion fittings is critical to accommodate thermal movement in PVC conduit systems. Use expansion fittings listed for use with PVC conduit. The NEC requires expansion fittings where the length change due to thermal expansion or contraction is expected to exceed 0.25 inches. Proper bonding of PVC conduit systems is crucial for safety and compliance. While PVC is a non-conductive material, metal components such as junction boxes and equipment enclosures must be properly bonded to ensure a lower impedance path for fault currents. Use bonding bushings or other approved methods to bond metal components to the grounding system, as per NEC section 250.92. When running PVC conduit underground, ensure that it is installed at the correct depth and protected from physical damage. The NEC specifies minimum burial depths for underground raceways depending on the voltage level and location. For example, for residential branch circuits rated 120 volts or less, the minimum burial depth is typically 12 inches. Consider using rigid metal conduit or encasing the PVC conduit in concrete for added protection in areas subject to heavy traffic or physical stress. The NEC specifies directing factors for conductors installed in raceways, including PVC conduit when the ambient temperature exceeds 86 degrees Fahrenheit, or when multiple conductors are bundled together. Consult NEC Table 310.15b2 for directing factors based on the number of conductors and ambient temperature. Failing to apply directing factors can lead to conductor overheating and temperature failure. When installing PVC conduit, be mindful of fill limitations to prevent overheating and ensure proper ventilation. The NEC specifies maximum conduit fill percentages based on the number and size of conductors. For example, the maximum conduit fill for 3 or more conductors is typically 40% of the conduit's cross-sectional area, as per NEC Chapter 9, Table 1. Overfilling the conduit can lead to conductor overheating and difficulty pulling conductors. When routing PVC conduit through fire-rated walls or floors, it's essential to maintain the integrity of the fire resistance rating. Use fire-stop materials and methods listed for use with PVC conduit to seal penetrations and prevent the spread of fire and smoke. Consult the building code and fire-stop product listings for specific requirements. PVC conduit is susceptible to damage from ultraviolet, known as UV, radiation over time, especially in outdoor applications. Consider using UV-resistant PVC conduit or coating the conduit with a UV-resistant paint or wrap to prolong its lifespan and prevent degradation. Always follow the manufacturer's instructions for installation, including proper gluing techniques, support spacing, and expansion fitting placement. Failure to adhere to the manufacturer's recommendations can void warranties and compromise the performance and safety of the conduit system. When making bends in PVC conduit, use proper bending equipment and techniques to avoid kinking or damaging the conduit. Use a conduit bender specifically designed for PVC and follow the manufacturer's instructions for heating and bending the conduit. Avoid using excessive force or heat, which can weaken the conduit and compromise its structural integrity. Prior to installing PVC conduit, carefully inspect it for any defects or damage. Look for cracks, dents, or other signs of damage that could compromise its performance. Do not install damaged conduit, as it may not provide adequate protection for conductors and could pose a safety hazard. When connecting PVC conduit to metal enclosures or equipment, use appropriate fittings and connectors to ensure a secure and reliable connection. Use PVC-coated metal fittings or connectors specifically designed for use with PVC conduit to maintain the integrity of the grounding system and prevent corrosion. Ensure that all connections are tight and properly secured. When terminating conductors in PVC conduit, use proper termination methods and hardware to ensure a secure and reliable connection. Use compression connectors, set screw connectors, or other approved termination methods to connect conductors to terminals or equipment. Ensure that all connections are tight and properly insulated to prevent shorts or ground faults. Proper documentation and labeling of PVC conduit systems are essential for maintenance and troubleshooting purposes. Label each conduit run with its purpose, voltage, and circuit number to facilitate identification and prevent confusion. Keep accurate records of the conduit layout and installation details for future reference. Regular inspection and maintenance of PVC conduit systems are essential to ensure their continued performance and safety. Inspect the conduit for signs of damage such as cracks, dents, or corrosion. Check for loose connections or damaged fittings. Repair or replace any damaged components promptly to prevent potential hazards. Let's consider the selection of the correct type of PVC conduit for the application. There are several types of PVC conduit available, each with its own unique properties and applications. Schedule 40 PVC conduit is the most common type and is suitable for general-purpose applications. Schedule 80 PVC conduit has thicker walls and is designed for applications requiring greater strength and durability. Electrical non-metallic tubing, known as the NT, is a flexible type of PVC conduit that is suitable for concealed installations. Choose the type of PVC conduit that is best suited for the specific application and environmental conditions. When selecting PVC conduit, consider the size and number of conductors that will be installed in the conduit. Use the conduit fill calculator or consult the NEC to determine the appropriate conduit size for the application. Overfilling the conduit can lead to conductor overheating and difficulty pulling conductors. Be sure to choose the correct size of PVC conduit for the number of conductors. Also, consider the ampacity of the conductors that will be installed in the PVC conduit. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The ampacity of a conductor is affected by the size of the conductor, the insulation type, and the ambient temperature. Consult the NEC to determine the appropriate ampacity for the conductors. Always choose the conductors that are rated for the application. For the type of PVC conduit in an area with a high water table or that is subject to flooding, use watertight fittings and seals to prevent water from entering the conduit. Water can damage conductors and electrical equipment and can also create a safety hazard. Consider measures to protect PVC conduit from physical damage, such as installing it in a protected location or using a more durable type of conduit. Physical damage can compromise the integrity of the conduit system and can create a safety hazard. For PVC conduit to be installed in an area that is subject to extreme temperatures, use expansion fittings to accommodate the expansion and contraction of the conduit. Extreme temperatures can cause the conduit to expand and contract, which can put stress on the conduit and fittings. Consider grounding the PVC conduit system in accordance with the NEC. Grounding the conduit system can help to protect people from electrical shock and can also help to prevent damage to electrical equipment. It is worth mentioning the types of fittings for PVC conduit and the correct usage. There are a variety of fittings available for PVC conduit, including couplings, elbows, tees, and adapters. Use fittings that are specifically designed for use with PVC conduit and that are compatible with the conduit size and type. Use proper gluing techniques when installing PVC conduit fittings. Apply PVC cement to both the conduit and the fitting and push the fitting onto the conduit until it is fully seated. Allow the cement to dry completely before using the conduit system. When cutting PVC conduit, use a sharp saw or cutting tool to create a clean, even cut. Deburr the cut end of the conduit to remove any sharp edges or burrs. This will help to prevent damage to the conductors when they are pulled through the conduit. When pulling conductors through PVC conduit, use a lubricant to reduce friction and make the pulling process easier. Use a lubricant that is specifically designed for use with electrical conductors and that is compatible with the conduit and conductor materials. Do not use oil-based lubricants as they can damage the insulation on the conductors. When supporting PVC conduit, use hires, straps, or clamps that are specifically designed for use with PVC conduit. Space the supports according to the manufacturer's instructions and the requirements of the NEC. Over-tightening the supports can damage the conduit, while under-tightening the supports can allow the conduit to sag. PVC conduit is a versatile and cost-effective wiring method that is commonly used in electrical installations. By following the proper installation practices, PVC conduit can provide years of reliable service. You can refer to the NEC for the correct way to install. Always consult with a qualified electrician. They can help you select the right materials and install them correctly and safely. Remember to follow all safety precautions when working with electrical wiring and equipment. Always turn off the power before working on any electrical circuit. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical wiring, hire a qualified electrician to do the work for you. It's essential to ensure the PVC conduit is installed in compliance with all applicable codes and regulations. In conclusion, PVC conduits can be safely utilized in a service under the specified conditions in Miami Beach, Florida, as long as they are properly installed and maintained in accordance with the NEC and other applicable standards.